Well, hey there, everybody. It is time again for Astronomy Daily Live. So, hope everybody's doing well out there in the universe and the world. I'm just sort of getting my smartphone running here, watching the live stream, keeping an eye on things as well as I possibly can. There it goes. There it goes. So cool, cool. Well, here we are again. It's 2 hours UTC, and we're back again, coming together each and every day to just, forget about pretty much everything else and think about the universe. Just think about all things astronomical. And, I do this pretty constantly, right? Throughout the entire day, I'm, I would say at least more than half of my thoughts are something astronomical, right? And that's how it's been for years and years and years. I guess it's just one of those habits now. Maybe a good habit, right? I mean, I guess there's a lot worse things, that one can think about. But they say that we all have about like 40,000 thoughts every single day, and most of those are the same over and over and over and over again. But it's one of the cool things with astronomical thoughts is that there's all this old stuff, right? And you're thinking about all this old stuff, that you already know and you've already heard and all that. But it's also science, right? So we're always learning new things. We're hearing about stuff, yeah. So it's always sort of new. It's always new, and that is one of the things that definitely sort of pulls me to it. Is sort of the novelty of this, and science in general, right? It's there's always new stuff coming up, and so yeah, always great. So hey there, Tom. I see Tom in the chat, and on the panel tonight is Bobby. Hey there, Bobby.
Hey.
Uncle Bill is in the panel too, so welcome.
Yo, y'all. What's up, nerds?
So thanks for
the location.
Yeah, thanks for coming in, you guys. It's always great, and yeah, I think this channel is slowly growing. I'm not really paying any attention to that much. I'm here to share a passion. But I'm also trying to sort of find my people, right? And here they are, right? And
if it's not for that, it's going to be that Friday night fever once again. High school football is back.
High school football. Great.
Yeah, you like listening? You like watching that sometimes too, or listening to that on the radio, or going to the game?
No, the last high school football game I attended was probably my high school football team, and that was 30 years ago. So yeah, no, haven't. The really, the only sport that I and it's kind of strange, right? I mean, I can't really even figure it out for myself, because I don't really, I don't like to see people getting hurt, right? I just don't find that fun in any way at all, right? So most of the contact sports, I'm sort of like, okay, if they like that, that's cool, right? But I'm not. But having said that, I can sit and watch rugby for forever, right? And I I think, and I think I've talked about this a little bit before. Um, Rugby absolutely perplexes me. I cannot, just by watching it, right? Now, yes, I could look up all the rules and I could, do all that kind of stuff, but that's no fun, right? That's no fun. I like to sit there and watch things. I guess it's the scientist, right? Um, I like to sit there and watch things and try to figure them out, right? Just by behavior and all of that. And let me tell you, I have watched hours and hours and hours of rugby, all different kinds of rugby, right? I know that there are at least two different kinds of rugby. Maybe there's more. I don't know. But I for the life of me, I cannot figure out those rules whatsoever. I just can't. I do not know how they how that sport works at all, right? It just looks like, I mean, it to me it just looks like almost chaos, right? And
Watched the whole movie on it, and I still don't understand.
yeah, I just can't wrap my head around it at all. And so that's one of the reasons why I watch it, right? Is because I'm trying to figure it out, right? But the other thing is, the one thing that I have noticed is that these are big dudes, right? These are big, mean dudes, right? They are super strong, super big. They could. I'm absolutely convinced, right, that any one of those guys out there could literally kill anybody else on that field. I mean, really kill them. Not just hurt them. They could do that too, but I mean, like death. So they have to have rules of behavior so they don't kill each other, right? So there have to be rules, right? There have to be rules. The other amazing thing I find is, you know, uh, in that kind of sport where they are, hitting each other so hard, right? They're tackling, they're grabbing, they're pulling, they're scratching, they're, the whole thing. Um, at least on the field, right? At least on the field, none of them take that personally, right? So it's not as if that guy is going after me, right, and tackling me. It's that guy is going after me as a representative of the team, trying to stop the team, from scoring, right? And that's one of the terms that actually confuses me a lot. Is that they don't score, right? They try. It's a try when they score, and I can't wrap my head around that. Anyway, this is not a rugby live stream. This is an astronomy live stream. So how did I get off on that? I don't know.
Not even a football stream, but going back to football, I can understand high school football and collegiate football, but NFL, they're making it more like one of those like one of those entertainment things. Like
Yeah.
some people say that wrestling is fake and stuff. I think the NFL can be like the same way too. They're just trying to like wash them down and stuff like that.
Yeah.
But collegiate and high school, I find no fault with that.
Yeah, cool.
Unless in collegiate you're a Bama fan.
Right. I've got a lot of respect for anybody that is doing what they enjoy doing. So if if the football players, if the American football players, you know, are having a good time, I am all for it, right? But having said that, compared to rugby, American football is you know, I mean, I don't want to upset anybody, right? But it's it's like, oh, you've got to wear a helmet, you've got to wear pads, you play for 30 seconds at a time, and then you take, you know, like a 2-minute break while you know, do the next play and stuff. Rugby is,
Well, you like take a Gatorade and stuff.
yeah, you know, rugby is like constant, right? The clock really never stops. It's constant. I mean, it is, you know, what, I think one half is like 30 minutes or 45 minutes or something like that. I forget exactly.
When I seen rugby, the only time they stop the clock if there is an injury or the referees want to reveal something, or when there was a
Yeah.
score and stuff.
Yeah.
And I
And
think there are 40-minute halves
40
as
minute
well.
halves. That's it. Yeah, that's right. Yeah. So, but it's constant, right? And I think that those guys do have maybe, you know, without going into detail, I think they probably have sort of a minimal amount of protection. You know what I mean? But you know, in terms of headgear and shoulder gear and shin gear and everything else, nothing, right? I mean, it's like they are just clothed, and that's about it. So you know, got to have a lot of respect for that. You know, banging around that hard and everything, oh, it can't be good, right? It can't
Now,
be good.
if you really was watching like the University of Arizona football,
Hmm.
would you like watch that instead, or what?
No, you know, as I said, I'm not really a sports fan all that much. And you know, quite frankly, I'd rather be working on some astronomical code or you know, watching an astronomical video or something like that than doing that.
Yeah.
Uh, so yeah, no, I've never really been into spectator sports. I played soccer as a kid and had a great time. I found um, that the position I was best at was actually right wing, and had had a great time doing that. But yeah, you know, as a spectator, I'm not too interested. I think as a participant, I probably would be, but you know, I mean, yeah, I'm not incredibly athletic, so you know, the
Yeah,
athleticism in me is up here. So
yeah. I think I would have been good in like in soccer and in basketball. But there, in my parish, in Louisiana we call our counties parishes.
right,
There's got to be at least one school in my parish that does that's more of a soccer oriented. All other schools are like football, baseball, softball, volleyball, and basketball. There's only one school that can do more than the onlyest place that you're going to do soccer is actually in Morgan City. I graduated in Berg in '07.
huh? Okay, yeah, cool, interesting. All right, well, let us turn to some things astronomical. And what I thought I would do again is turn to an object of the day, and let's definitely do an NGC object. And I think what I'd like to do, if it's okay, is you know, maybe find an NGC object that the HST has looked at, so we can, you know, play with the images a little bit and see what we can come up with there. So so let's do that. And I don't know how. You know, I don't want to try too hard, and I don't want to throw out objects just because the HST hasn't looked at them, but let's give this a little bit of a try, and see, just sort of see how it goes for starters here. Now I need to pull up my random.org here, random.org, because I think this is a great way to sort of explore, you know, different kinds of objects, and you know, randomizing it sort of, you know, takes me completely out of the loop, right? I mean, I have nothing to do with this at all, except I am designating what the range of numbers is, right? And in the NGC catalog, there are 7,840 objects that cover the entire sky, and so yeah, let's see what random.org says here, and then we'll go to the HST archive and we'll take a look at it, see if it's there, and if it is, we'll take a look at it, see what it is, and then we'll go from there, huh? All right, here we go. Bam! 7123.
And there, I'd like to welcome Crystal Gems Caplet. What's up, Crystal Gems?
Hey there, Crystal. Nice to see you in the chat again. Thanks for coming in again. It's very, very awesome to have you here. So we're going to be doing sort of an object of the day with a little bit of a twist. I want to see if the HST has ever looked at this particular object, NGC 7123.
Now, is it just HST or there's other telescopes?
This is just the HST. Yeah. This is just the Hubble Space Telescope. Okay, so
That one is very far south. That's in Indus constellation.
cool. Okay. Well, let's see if HST has looked at it here. The chances are extremely low, but you know, we have to try. That's what science is all about. You got to try stuff. Nope. Okay. So I think at this point, I'm going to choose another one, right? Or I'm going to have random.org choose us another one. I hate to, you know, as I said, you know, bypass any of these, because every single one of these is unique and incredible, right? Now, it's probably a galaxy. Is that true, Uncle Bill?
7123 was a Galaxy S0.
Okay, yeah. All right. Well, I'm going to try another one because, yeah, I'm wanting to get some pictures to play with inside of GIMP, right? I just have the urge. So here we go. We're going to try another one. Bam. 6100. Okay, let's try NGC
6100.
6100. See if HST has seen that one. No, it has not. Yeah. Dang it. All right. I don't know how.
That one was in Serpens.
Okay. Okay. Well, at least I was in the north.
Yeah.
For what it's worth. So, all right. I'm gonna try that. I'm gonna try this a couple more times, and then I'm gonna give up. All right. Here we go. 4403.
4403.
Has HST seen it?
That one's in Virgo.
Oh, nope. Okay, so that's probably a galaxy too.
Yes, Galaxy SBB.
Oh, okay, interesting. Man, I hate to bypass all these. Let's try just a couple more times, and then if not, we'll forget the HST thing, and we will move on. So, all right, a couple more tries here. 2094. That number.
2094.
No, I think it's 29. Oh, yeah. 2094. My dyslexia.
That one's in, I guess you pronounce it Dorado. Is it's a southern constellation again.
Yeah.
And it's a cluster.
What's up, Andy Cowie?
Atta is in the chat.
No, it's not Atta. It's Andy.
Oh, Andy.
Cowie.
Andy. Hey there, Andy. Nice to see you.
And Crystal's here too. Hello, Crystal.
Yeah. All right, we're not having any luck here at all. Come on, HST. Come on.
Come on, your mama can do better than that.
Here we go. Come on, come on. 381.
Oh boy.
381. Come
So
on.
that's a new object, 381.
Correct.
Okay.
Oh, it's not there either.
NGC 381.
So,
That's an open star cluster in Cassiopeia.
Oh, nice. Ah. Well, let's try one more.
That one is also known as CR10.
Okay. Let's try one more. If there isn't any HST images, we'll just go with it, whatever it is. Here we go. 3053.
3053.
I'm just getting tired of this. Come on, come on, come on. Here we go. Ready?
That's a radio galaxy, also known PGC 28631 and UGC 5329. And it's in Leo.
Okay. Well, HST has not seen it, but I'm going to go with it because this is an object of the day. This isn't a picture of the day. So
It's a radio galaxy, so maybe you find some cool radio images of it.
yeah. Let's see. So we're going to go over to Sinbad,
and we got check the chat. But then we got a new person. I don't know how you pronounce it and stuff.
Oh, okay. All right. Yeah, that's. I don't know either. I'm not even going to try that one. But welcome.
Gudmundur or something, maybe?
Yeah. Gudmundur. Gudmundur. Cool. Nice to have you here. Thanks. This broadcast is all about the science of astronomy. We just talk astronomy for like an hour each day, starting at 2 hours UTC. And yeah, it's just a fun, casual get together of friends, get together every single day, and we talk astronomy. And actually today we're looking at a object that's called NGC 3053. And so we're going to pull it up here on Sinbad, which is one of the many astronomical databases, and we're going to find out some things about it.
All right, the sun is very close to that spot, so my stellarium finder charts will have to be at a different time of the year.
Yeah, absolutely. So what this is showing, right, is it's showing the coordinates in the sky. These first three numbers are the right ascension. So it's 9 hours, 55 minutes, 33 seconds. And then these last three numbers are the declination. Plus 16, 25.
Thank you for appreciating that. We always love astronomy. I think it's a very good thing. And you're always welcome to join anytime.
You can come in anytime you want. Absolutely. Absolutely. I'm here every single day. Most of us here are. So, yeah, come on in. If this time isn't exactly good for you, catch the show later. Spread the word too, for sure.
Yeah.
We're looking for you. All right, so let's take a look here. So they're calling this and actually I wanted to go off on a little bit of a tangent here, talking about the different morphologies of galaxies. Now they're calling this.
I wanted to ask about that because I don't know what an SPA is.
Okay. Yeah, you know, it's kind of interesting, right? Because according to Simbad, they're calling it an E, which I think is some kind of elliptical, right? But if
really?
Yeah.
Well,
but,
see, my stellarium's supposed to be getting its stuff from Sinbad. Supposedly, I'm looking at Sinbad data, but I got an SB colon lowercase a.
Okay. Well, you know, I would definitely say, looking at this picture, right? Looking at the picture, that it is most definitely a spiral galaxy, right? That is not an elliptical galaxy. That has these nice spiral arms, right? And SD, the D is just sort of describing the compactness of these arms, right? The most compact spirals are like S zeros, and then there's SA, SB, SC. I guess there's SDs as well. But let's go over and just sort of see what we can find out about galaxy morphologies. I'm just going to do that because it has definitely changed and evolved over time, right? When, you know, I mean, even 100 years ago, not quite, maybe a little bit more than that now, we didn't even know that galaxies existed, right? I mean, we called these things nebulae because they were, you know, fuzzy looking. We thought, you know, they were just, you know, clouds of gas and dust. Had absolutely no idea what they actually were until, you know, pretty recently, as I said, you know, in the past 100 years, for sure. So here is sort of the typical, what's called the Hubble sequence. And this also sort of shows at least one idea about how these galaxies evolve, right? That all galaxies might start out as you know, elliptical, and then you know, sort of change into spirals as more gas and dust gets made, I guess. Yeah, not quite sure, but here's sort of, you know, the basic, very, very basic different types, right? So, you know, you have the ellipticals, which are sort of based on their shape, right? So E0 is almost exactly round. E7 is highly elongated, but these ellipticals don't really appear to have a lot of gas and dust in them, right? It's just stars, right? It's just stars. And then, at least according to the theory, which you know, I'm sort of like, well, okay, I'm not sure about this, but you know, this is the storyline at the moment. These things sort of, you know, can split off into two different kinds of spiral galaxies, either regular spirals, right? And they're showing examples here. You see how an S0 is almost like an E7, right? Really, really, really close. And then an SA, you're starting to see some arms, right? SB, this is sort of a bad example, but you're seeing a little bit more arm there. SC, more arms. SD, I guess, would even be more. And then spirals can also have...
classification system is the Milky Way?
it's currently thought that the Milky Way is an SBB, I believe. So I think they think that they know that the Milky Way does have a bar, and that it has, relatively open arms. Forget how many arms. Maybe like 2 or 3 main ones, something like that. So yeah, ours is sort of, I think, sort of like that one. But the problem with knowing for sure is exactly the same problem you would have taking a picture of the outside of your house from inside, right? It can't be done, right? You can take a picture from the inside, and you can see the walls, right? You can see the walls, so you can get a pretty good idea of the shape, right? Pretty good idea. But really, the only way to know for sure what our galaxy looks like is to be way outside of it, and we're not going to be doing that anytime soon, not that I know of. So it does get more complicated, I think. Let's see, they've got a bunch of other charts here. Let's just go. Okay, so that is the Hubble sequence. There's also this, I'm not quite sure how to pronounce that, Viva-Cullier's system, which basically follows exactly the same thing. It's just sort of a different name scheme.
Goodmunder, he is from Arizona.
Oh, you're from Arizona too. Cool. I'm in.
No, I think he's from Iceland.
Oh, okay. I'm from Arizona. Yes.
I'm staying in Illinois too, but are you like originally from Iceland, or are you just like live in Illinois? Because he did to say about being a jack of all trades and being Icelandic too at the same time. If he was like catching up with the chat and stuff.
Sweet. Yeah, so...
And of course, I'm from Louisiana. And I think, Uncle Bill, you're from Georgia, right?
Originally from South Carolina, but I claim Georgia. I've been adopted here, and Georgia don't want to let me go, so I might as well call myself a Georgia redneck.
Might as well.
Copa Bogor, is that in Iceland?
I'm going to look at the chat here, too. Cool. Well, that is very, very awesome. I think that's most definitely the first Icelandic friend that we've had here. You're very, very cool, if that's the case. We've had a couple come in from like Australia, and Andy, I think you're in England, yeah? I think so. So yeah,
It's very nice that you come and join with us.
Yeah. I think it's so cool that we can do this.
Tom's in Illinois.
Tom's in Illinois, yeah. There are actually nice people there.
Watts in Pennsylvania. I think Andy, where are you from?
Yeah, I think he's England. Cool. Well, Goodmunder, if that's how it's pronounced, sorry if it isn't. Glad you're here. Glad you found us. Yeah. How did you find us? I'd like to know. It's kind of interesting. So anyway, as astronomers do things, we like to complicate things as rapidly as we possibly can, and that's what we've done in terms of trying to classify galaxies. And it's hard to classify them because, as I said, all of them are very unique, right? There isn't one that's exactly the same as the other, but they do tend to fall into families at least, and various people have tried to classify them to certain levels of detail, and it's just a way of trying to understand what is going on, right? So yeah, it's kind of interesting that Sinbad is, it says morphological type E, so that's I would say completely wrong. But yeah, let's move on. Let's so actually, this is a relatively bright galaxy. Now in the B band, which is part of the visible band, looks pretty faint, right? 13.7, pretty faint. You need to be able to see that with your own eyes. Oh, you need at least a 12-inch telescope to see that, at least. Because the brightnesses of galaxies aren't based on just the brightness of sort of the central part. It's sort of the collective brightness of all of
that. Just about makes my stellarium screenshot silly, doesn't it?
And Goodmunder said that you appeared on my regular suggestions. Must have had liked your channel recently. What's going on is a ballot question.
Very cool.
And I found out where he's at. He's actually at Iceland.
Iceland. Wow, that is
and
fantastic.
Here's Bob Dog.
Hey there, Bob Dog. Nice to see you in the chat too. So, as you can see, it's pretty faint at visible wavelengths, but pretty bright towards the infrared. J, H, and K are more towards the infrared. So yeah, so U, G, and R are sort of in the visible. I and Z is more towards the infrared. And as you can see, yeah, pretty faint, visible, brighter in the infrared. And usually what that means is that there are, quite a few red stars. Maybe you can guess, that they're older stars. So, these spiral galaxies seem to be more evolved, maybe. Yeah. All right, let's keep going down.
Does that say anything about the radio brightness? Because I'm showing it as a radio galaxy.
Yeah, it's labeled that way here, and not quite sure why it would necessarily be labeled that way, except it's pretty bright in the radio. But yeah, we'll try to find out something about that.
You're for radios as well?
Say that again, Bobby.
Are you for radios as well?
No, not really. I mean, other than just being a general purpose electronic geek, it's just my stellarium. Like I said, I thought my stellarium was getting its data from Sinbad, but I show it as a radio galaxy, spiral barred A-class.
Yeah, cool. That's part of doing science, is absolute confusion most of the time. No problem. No problem.
It happens.
It happens. So here's a bunch of other names for that same object, and these are just different catalogs, right? So somebody has done a survey looking for certain characteristics, and they've found those characteristics being a part of this galaxy, and so it becomes part of a catalog. So just a bunch of different names. a bunch of different names there. I'm not. Yeah. Well, we'll continue to look around to see if there's any radio info here at all. I'm tempted to go into the references to see, but let's look at the pictures. I always like looking at the pictures. So this, let's see, this image is from, I think this is from I think it's from the Sloan Digital Sky Survey, if I'm seeing that right.
Now, what does Aladdin does with all those imaging things? Are they mostly like telescopes, satellites, or like ground decks?
Well, each one of these surveys on the left here is a different instrument. You know, either a different telescope or a different kind of detector, anything else. So yeah, I usually like to look either with the Digital Sky Survey, which is this one, or
and Tom, you said enough.
What's that?
Tom said enough. I don't need science to be confused. It comes naturally.
Yeah. Well, ain't that the truth? So yeah, these are just the different surveys, different kinds of telescopes that have looked at this object, and I don't see any radio ones here, but I'd be surprised if there were any. So yeah, this is just a visible band image. So I'm going to zoom out here a little bit just to sort of look around, see if there's anything else.
I think it's true as we get older. And Gamunder says the way it's often described can be very confusing.
Yeah. Yeah. You know, that's one thing as a scientist, you really do have to be patient, right? You have to be patient with yourself first and foremost, right? So, you know, if you're confused about something today, well, you know, maybe tomorrow you'll be a little less, and you know, the next day you'll be a little bit less, and after a while, you know, you'll look back and be like, why didn't I understand that? That's you know, obvious. So yeah, you know, it's a process. It's a process for sure. So yeah, there seems to be a few galaxies around this. Now, whether these galaxies are, you know, sort of associated with one another, probably not. You see how big this guy is, and you know, sort of how small that guy is. Probably this guy's behind this guy. Probably. So, but yeah, there's a few here. Pretty much everything else is a star, and those stars are all, of course, part of the Milky Way galaxy. So, pretty cool. There seems to be some weird photographic effects here. You know, some optical effects of some sort. That's some kind of weird thing on the picture itself. Here's another big galaxy over here. It's probably another NGC object of some sort. Gonna zoom in on that. That's another nice little spiral. Pretty cool. So nice. All right. Well, let's go back to.
I found NGC 3060, about half a degree north and east.
Okay, yeah, that one was north and west. So yeah, I don't know. Let's take a look and see. There aren't
half a degree off. I don't know what I said.
And Gamunder actually asked 4 professors what you call the science of explaining, and said there's no name yet. And it likes to advance the science of explaining.
Okay. I'm not quite sure what the science of explaining is either.
It's what we say. We may know the first part and still learning the second part.
Yeah. Yeah, I think so. I think so. All right, so let's see. A couple of references here. Hasn't really been studied all that much, but let's. I'd sort of like to get down to why they're calling this a radio galaxy. Now, here's one here, right? They're looking at hydrogen data from Green Bank, Parkes, and the Arecibo telescopes. Those are all radio telescopes, so has definitely been looked at with radioscopes. Let's see, sodium excess objects, that's kind of interesting. The radioactive galactic nuclei population. Okay. Galaxy Redshift catalog. The digital H1 profile catalog. See, a lot of these papers are just sort of reporting, you know, observations. You know, they've made an observation and they put them into a catalog, and that's about all that we know. So here's a radio observation, actually looking again at the hydrogen lines. It's a 21 centimeter line. With I've never heard of the Nanke radio telescope. Let's take a look at that. It's a little old, but you know, who cares?
Why not?
Why not? We've got to follow our noses here. That's what science is all about.
Those paid to do and stuff.
Yeah. All right. It looks like there is a paper available. Yay. We are now attempting to automatically create some PDF for the article source. Ka-chunk, ka-chunk, ka-chunk. Here we go. So this is obviously some kind of a series of papers because this is number 13. So let's see, 21 centimeter line measurements of 452 galaxies with the Nanke radio telescope. The Tully-Fisher relation is one of the many, many ways of trying to measure distances, if I remember correctly. And JH and K is actually, those are towards the infrared. So, you know, they've looked at this in a couple of different ways. Let's see, here's the abstract. Abstract is sort of a summary of the entire paper. So they are looking at a bunch of galaxies, 452 of them, with this radio telescope, the Nanke radio telescope. Sort of want to find out about that too. They'll probably talk about it.
Okay, Gumunder says there's a little chance of a population like we are used to around the move at the galactic nuclei. Maybe in the future we will know how far away from medium quasar normal life could exist.
Yeah, you never know. You never know. The thing about life is that you know, it's going to surprise me if we never find nothing at all, right? I think it's the opposite of that. I think life is everywhere, and it's just a matter of I think it's just a matter of time, you know, before we find it. So, but yeah, AGNs, you definitely don't want to be around those. You know, we find ourselves in sort of a unique position, somewhat rare, right? We're part of a galaxy that is not a very active galaxy at all, right? At least at this time, and we're revolving around a star that is the same, right? It's not very active at all, and so, you know, in a certain sense, you know, we're kind of lucky, right? You know, because we look out and we see, you know, extreme violence, right? I mean, exploding stars, AGNs, where you know, life may have a pretty hard time, you know, lasting for very long. You know, maybe life, you know, can get going there, but you know, to last, maybe not. You know, maybe we are, you know, one of the unique places where, you know, it just so happens that everything's sort of benign and everything's sort of calm, and you know, life can take off. Don't know.
We're in the Goldilocks zone of a Goldilocks star and the Goldilocks distance from the core of a Goldilocks galaxy in a very dangerous universe.
I totally agree. Yeah, I totally agree. It's just right. All right. Well, let's take a look at this here and see what we can find. I don't know if there's going to be any pictures, right? This might just be, you know, sort of spectral information. It's hard to know. So let's find out about this this observatory, though, the NGC radio telescope. Let's see. We'll go down here.
We are so Goldilocks, so let's make the best of it, says Gamunda.
Yes, totally. And I am. Let's see. So, wow. Sometimes these papers just totally fly over my head. Huh. I'm already a little like, huh, what exactly are they talking about here? 20%. Okay, so they're just talking. Yeah, you know, so this is just an ongoing project, right? And let's see. They're definitely looking at these in neutral hydrogen, which of course, you know, can only be seen with a radio telescope. Let's see. Okay, so here we go. The NGC radio telescope is in France. It's a single dish. It's a 94 meter dish. So that's a pretty big dish, all right? Pretty big. It's got pretty good resolution, 3.6 arc minutes east and west and 22 north-south. It's pretty good. Okay, and let's see. So they've got a spectrometer on it, and then they can split that up.
Commander.
Yes.
Nice to join with us.
Yeah, thanks for coming in. Come in anytime you want. As I said, I'm here 2 hours UTC pretty much every single day. Once in a while, I'm not able to, but on rare occasions I can't. But for the most part, we are here. So thanks for coming in. Let's see. Yeah. So these are spectrometers, for sure. 50 megahertz bandwidth. Centered on 1387. So yeah, you know, the 21 centimeter line is actually like around I think it's around 1436 or 1420 or something like that megahertz. So this is sort of on the short end of that. Let's see. Let's see what else we got here. So yeah, just describing their different ways of collecting their data. I'm going to zoom out a little bit here. It's a little hard to see all of that. Yeah, this is probably a little bit more technical than what I can get into here just by skimming. But oh, here's some spectra. So let's look at the. So yeah, these are some of the profiles. So yeah, these are spectra taken at 21.
Okay, 2 hours UTC for me is actually 9 o'clock p.m. Central Daylight Time, or like 2100 hours Central Daylight Time. And I think Cosmic is about 7 o'clock p.m. or 1900 Mountain Standard Time.
Yeah, you know, part of the thing,
ring that bell and you won't miss it.
yeah, you know, smash the notification bell. You won't miss it at all. But you know,
it's every day,
every single day. Yeah,
yeah,
you know.
Yeah, I was following. What's also good about Google is you can find out what time it is in a certain place and time, and I just found out that he uses the GMT, the
Cool.
UTC and stuff.
Yeah. You know, when you do astronomy, time is actually the measurement of time is really, really, really important. So you know, being able to figure out time zones and all that kind of stuff, I'm going to leave that up to you. That's why, you know, this live stream is at, you know, one time. Trying to do, you know, the translations and stuff, I'm going to leave that up to you because, you know, that's a good exercise. So yeah, you'll have to figure that out. And you know, like Uncle Bill said, you know, like if nothing else, smash the bell and you will be notified for sure. So these plots are really hard to see. They're getting a little bit grainy, and I can't even tell what exactly these are. These must be different objects, right? And I think the x-axis here is they like to look at things in terms of velocity dispersion, which is a yeah, you know, not being a radio astronomer myself, I'm not quite sure why they like to look at things that way.
Yeah. Good night, Commander.
Yep. Good night. Thanks for coming in. But anyway, here are some spectra, nevertheless, of at least some of the galaxies that they looked at. I guess, you know, probably why it's called a radio galaxy is that it is just you know, really, really bright towards the radio. And, you know, some galaxies are, some galaxies aren't. So, but yeah, you know, moderately interesting. I mean, I'd like to understand this a little bit more. I'm not quite sure, for instance, you know, if there's any kind of useful information in here, right? I mean, I can look at like one of these and say, okay, well, there seems to be, you know, something going on here, but here it just looks sort of like noisy, wiggly lines, right? I'm not quite sure if you know, there's any kind of information in there whatsoever. I'd have to study up on radio astronomy a little bit more to really know. Let's look at the rest of the axes are graduated respective in kilometers per second. Yeah, so it's a velocity thing. So, whew, yeah. Complicated stuff, for sure. It's a long paper, too. It's like 21 pages long. Holy moly.
Yeah. And overtime, too.
Oh, yeah. Well, we're always going to go overtime because we're casual and loose here. TF residuals. I have absolutely no idea what that is. Absolutely no idea. It's kind of interesting, though, that there's, you know, I'm sort of assuming. Let's see. Well, it doesn't say, but you see all these black dots, and look how they hit this hard cutoff, right? There aren't any black dots down here at all. So whatever this is, I'm not exactly sure you know, what this is showing, but it seems like, you know, there's sort of, you know, some kind of a physical limitation there. It's hard to know. Way beyond me, for sure. Some fun math there. Yeah, these guys have really gotten into it deep.
There's lots there. Stronger delay, the difference in gas as Eddie Cowley.
Let me look at the chat here. Okay, yeah. All right, well, I don't know if I particularly got any satisfaction out of that paper at all. It's
I guess sometimes you can't just get no satisfaction.
No satisfaction whatsoever. So these
Crystal Jam says, I love when we see different forms of data.
Yeah, I do too. I just, you know, I like to be able to understand it a little bit more. And, you know, with time, right? With time, and if I really, you know, stared at it a while and thought about it a while, I probably could. But yeah, you know, I mean, as I said, you know, in so many ways, we're you know, 3-year-olds, you know, trying to learn to read, right? And when you're a 3-year-old trying to learn to read, what you do is you look at the pictures, right? You look at the pictures, and over time, you start to understand that there's a relationship, right? You know, between the pictures and the words, and that's how one learns, right? So we're doing pretty much the same thing here. Oftentimes, you know, we'll look at a paper like that, and you know, I most definitely won't have a clue what they're talking about at all. So I like to look at the pictures and you know, try to get something out of them, at least. Let's see if there's any other.
Have you ever read that? Are you a fan of Star Wars?
Me? Absolutely.
Yoda always said, "Do." There is no try.
That's right. That is absolutely true. Absolutely true. You just got to do it. Actually, Mr. Rogers said that too. Just do it. You've got to do it.
Yeah, well, I would love that, even though it might take a lot of people off. Can't somebody else just do it?
Yeah. All right, we're gonna try to find this paper. Ooh, that's not a good sign. That's not a good sign.
It's one of those Google Chrome security things.
Yeah, yeah. I like to, I usually trust those things. Let's just go for it here. This is from 1998, so this is getting a little bit old. But let's just try.
40 years.
Well, it's only 20. But still, that's quite a ways away. Let's just look and see if it's in archive. I doubt it. I seriously doubt it. So we're going to search by title here. So you can search by all kinds of different ways. And then if you go, to the advanced search, you can even, even more specific. I don't think this is going to come up. I think it's a little too old. No. Oh, man. Now, those of you who have watched this live stream for a while know that I'm pretty stubborn when it comes to trying to find papers and stuff. But oh man, I'm sort of thinking that this thing might just beat me. This
beat the
is
living tornation out of you.
This is an HTML. Oh no, I don't like that either.
Yeah.
I mean, probably they just haven't updated their security certificates, their SSL stuff.
Yeah, watch that if you're on a Chromebook too.
Yeah,
I think it's like that built-in NI virus.
Yep. All right, well, I guess we're going to have to skip that one, but that had actual pictures, right? That's sort of why I wanted to get into that a little bit.
And what's the point of having it if you've never updated your thing yet?
Yeah, yeah. Okay, so now we're going way back in time. Multivariate data for 400. For some reason, 492. They really like to use that number.
And I think Jules might have a video that says there's a reason why Google Chrome does that for a reason and stuff. I'm just not sure Jules has a video about that.
I'll have to try to remember to look into that a little bit. So yeah, not really seeing much about this poor little galaxy. That's unfortunately that's sort of common, right? That you have these amazing objects, right? With hundreds of billions of stars in them. They're unique in their own way, and nobody's really looking at them really hard.
And I think it's kind of crazy about how super old these papers can be and will be sometimes.
Yeah.
I was thinking about like a paper made like in the 19th century or early 20th century will have some type of cursive manuscript or something like that.
Yeah, they probably would. They probably would. All right. Well, sometimes you win, sometimes you lose. NGC 3053 is a beautiful spiral galaxy. It's absolutely gorgeous, right? But for some reason, not very well studied. So, well, as I say, sometimes you win, sometimes you lose. But it is looking like we're getting.
Stop believing, like in the song and Journey.
Yeah, yeah. No problem. No problem. That's one of the great things about having a daily live stream, right? Is that Some days are diamonds and some days are stone. So no problem. No problem at all. It's all awesome in terms of, looking at astronomical things and thinking astronomical things for a little while. So yeah, I think it's time to exit these waters for now. By the way, this is the first live stream of September. Go ahead, Uncle Bill.
All right. Quick shout out before we sign off. When you leave here, Fraser Cain is live right now with a telescope stream on YouTube. Which one of his channels is it? Hang on. It's his personal channel. It's under his name.
Yeah, put that on the Discord. I'm going to turn on the Discord, and I might find that link from there.
I've got it up on the other computer right now, so
Is it YouTube?
Give
Yeah.
me 5 minutes
YouTube
after
or
the
Twitch?
Huh? It's on YouTube.
Okay.
Okay, it's his channel, Fraser Cain, and he's doing a live stream right now. 3 minutes after the stream ends, I'll put it in the Discord.
Okay, nice.
Or I can try searching for it.
Yeah, I think is his YouTube channel. Is it Fraser Cain or is it F Cain?
F Cain is the Twitch. His YouTube channel is Fraser Cain with the space.
Gotcha. Yeah, so just do a search for that there. I'm probably gonna bop over there for sure. I'd like to see what he's up to. So cool. All right, well, yeah, I am definitely getting called. So I think I'm gonna exit this for now. So thanks for coming in, everybody. This was really, really great. Sort of a bomb in terms of the object, but that's how it goes sometimes. All right, well, take care, everybody. Have a great evening, a great day. Smash the thumbs up if you so desire, or the thumbs down, whatever you like. All right, I'm going to get out of here. Take care, everybody. Bye.
Later.
Later now.